Hello friends, I hope you are doing well and welcome to Login Science. This is our lesson 3 of 6 on sequences and series. In today's lesson, we'll be covering geometric sequences. Okay, before I can start with today's lesson, I'd like to remind you and encourage you to subscribe to your channel and activate the notification bell so that you can be notified every time I post new content. And you can see down below is my name and the email address at which you can reach me if you would like to contact me via an email. Okay, let's start with our lesson. Let's say you have this sequence 2, 6, 18, 54, and so on. Okay, let's say we want to check if this sequence is an arithmetic sequence. What we normally do, if you remember from the previous lesson, is to check if there is a common difference between consecutive terms. Okay, let's see. From 2 to 6, you can see there is plus 4. From 6 to 18, plus 12. I don't know if you can see that. From 18 to 54, it plus 36. If you take 54 minus 18, it will give you 36. So you can see the difference is 4, 12, 36. So there is no common difference here because the difference is changing. It keeps on changing. It's 4, 12, 36. Unlike in our previous lesson where we saw arithmetic sequence, there was a common difference and it wasn't changing like in this case. So this sequence can't be an arithmetic sequence. What is it? Let's see. If we check, there is something else which is happening here. I don't know if you can see, like from 2 to 6, there is actually multiplication by 3. And from 6 to 18, multiplication by 3. From 18 to 54, multiplication by 3. So you can see what they are doing is to multiply by the same number to get the next number. So they multiply the previous number by the same number to get the next number. So we can see clearly this is not an arithmetic sequence because there is no common difference. So I can erase this. We don't need this. Okay. So what is this sequence called? If you are multiplying by the same number to get the next number, what is it called? This is referred to, this is a geometric sequence. So we say in a geometric sequence, there is a common ratio between consecutive terms. So we use the letter R for common ratio. So in our case, 3 is the common ratio. And this type of sequence is known as geometric sequence. So you understand that this is not an arithmetic sequence because there is no common difference. Okay, and to find the common ratio R, we take the next number divided by the previous number. You can see T2 divided by T1. And the same is true if you say T3 divided by T2. You can continue, and in general, we can say it's Tn divided by Tn minus 1. So this is the next number divided by the previous number, the next number divided by the previous number, the next number divided by the previous number in the list or in the sequence. So this is how you find your ratio for a geometric sequence. And there is also this formula. If you want to find any term of the geometric sequence, we use this formula, which is Tn is equal to A times R to the power of n minus 1. So what are the letters in the formula? A is the first term. You can see even in the previous lesson, A was the first term, and here too, A is the first term. And R, you know, it is our common ratio. So let me write it down. R is the common ratio. Okay, so I hope you are following me so far. You understand what a geometric sequence is as compared to an arithmetic sequence. Okay, let's move on to some example so that you can understand on how to use the formula and the rest of the geometric sequence. Okay, example number 1. Let me read the question. Given a geometric sequence 1, 2 over 3, 4 over 9, and so on. A. Determine the next two terms and the 11th term. B. Which term of the sequence is equal to 32 over 243? Okay, it says solutions. Okay, let's start by solving for the next two terms. So that is T4 and T5. Okay, you can see we have T1, T2, and T3 in the sequence. So we need to find T4 and T5. Okay, we can use this formula, or you can do it the simplest way, I believe, is to find the ratio and then multiply the previous number by the ratio to get the next number. I don't know if you are getting it. You multiply the previous term by the common ratio to get the next term. So let's start by getting our common ratio. So it will be the next number. Let me use 2 over 3 over 1. So the next number divided by the previous number, which is also true if you say 4 over 9 over 2 over 3. And this will give you 2 over 3. This is true. So our common ratio is 2 over 3. Now you see the simplest way is to just multiply the previous term by the common ratio and then you get the next term. So we need T4 and T5. This is what the question is asking for. So T4 will be, you take the previous number, which is 4 over 9, you multiply by the common ratio, which is 2 over 3, and then it will be, what is 4 times 2? It's 8. What is 9 times 3? 27. And now what is T5 now? You still take the previous number, you multiply by the common ratio. Now the previous number is T4, which is 8 over 27. You multiply by the common ratio, 2 over 3. So it will give you 8 times 2, it's 16. 27 times 3, it's 81. You can see we have the next two terms, T4 and T5. We have solved for it. Now, T11, I can still use the same method, but it will take me time. I will have to multiply by the common ratio. so and so on. You multiply the previous number by the common ratio to get the next number until you get your T11. That will be waste of time. So the simplest way now for T11 is to use the formula. You can see here, I wanted the next two terms. They were not far from the three terms, so I just used the common ratio. I could have used the formula to get my T4 and my T5. Now in the case of T11, I now need the formula. So I'll use this formula for T11. What is A? Remember A is our first term. So it's 1. And what is the common ratio? We found the common ratio. It is 2/3. And what is N? N, the position of the term we are trying to find. It's 11 minus 1. So you have T11 is equal to 1 times everything. It's 2/3 to the power of what? 11 minus 1, it's 10. So T11 will be, let's use the calculator. I've got my calculator here. So it will be, you have 2/3 to the power of what? To the power of 10. So you have 10, can you see? 10 24 over 59,049. Okay, let me write it. It's 10 24 59,049. So this is our T11. Can you see that? Okay, we have solved for question A. Now let's move on to question B. Okay, question B. Which term of the sequence is equal to 32/243? So the question is asking us for T-watt is equal to 32/243. Or you can say the question is asking for the value of N. Can you see that? So I'll need this formula to solve for question B. So in the place of Tn, I'll put 32/243 is equal to A. What is A? The first term, 1. Times R, we calculated R, the common ratio is 2/3 to the power of N minus 1. So you can see, and this will give you 32/243 is equal to 1 times everything there. So it's 2/3 to the power of N minus 1. And can I change my 32 like 2 to some power or 2 to some exponent? Can I change it? Can I also change my 243 like 3 to some power or 3 to some exponent? So I'm trying to cheat. I'm trying to change my 32 and my 243 to the same base as what I have on the right side. Let me see. So what if I said 2 to the power of 5? Is it possible? Yes, this 2 to the power of 5 will give me 32. What if I said 3 to the power of 5? Yes, it will give me 243. You can check it with your calculator. You'll see that it is true. So I tried to cheat by looking at what I have on my right, the bases I have on my right. So I tried to change the numbers I have on my left, like the same base to some exponents. So it worked. You can cheat like that. And you say it's equal to what you have on your right, this one. And since the exponent is the same 5, 5, I can write this as 2/3 to the same exponent. It's true, the law of exponent, and equal to what I have on my right. Okay, now we can see my bases are the same, 2/3, 2/3. So I can equate my exponent. Let me do it here. So since my bases are the same, I can say my exponent are equal. So it will be 5 is equal to n minus 1. And when we take minus 1 to this side, it will be plus 1. So you have 5 plus 1 is equal to n, and n is equal to 6. So which term of the sequence is equal to 32 over 243? It's n equal to 6. So it is T6. Okay, let's move on to example number 2. All right, let's do example number 2. Let me read the question. The first 4 terms of a geometric sequence are 5, x, y, 320. A. Determine the value of x and y. B. Which term of the sequence is equal to 81, 920? Okay, solutions. Okay, question A is asking for the value of x and y, and we are told that this sequence is a geometric sequence. So our sequence is a geometric sequence. Okay, so we need to solve for x and y. Can you see x is t2 and y is t3? So x is the term after 5. Can you see that if we have the common ratio, we can just multiply 5 by the common ratio and get the next term, which is x. And if we have the value of x, we can multiply x by the common ratio to get the next term, which is y. Can you see that? Okay, so we say the first term is 5. So a is equal to 5. And we need this formula to solve for the common ratio r. And if we have r, then we're going to multiply 5 by r and get x, and then multiply x by r and get y. So we need to replace Tn with a term in our sequence, and we can't replace Tn with the first term, in this case 5, because if we replace Tn with the first term, you're going to end up having one side of the equal sign equal to 1, and you know any number to the exponent 0 or to the power 0 will give you 1. So it will not help you to solve for r. So it will be wise to use the other term. So in our case, we can only use 320. So Tn will be replaced with 320. And what is A? The first term 5. R, we are going to solve for R. And now what is N? N is equal to 4. Can you see that 320 is T4? Because this is T1, T2, T3, T4. So it is the fourth term, and N is equal to 4 minus 1. And we have 320 is equal to 5. R, 4 minus 1 is 3. Okay. And you divide by 5 on both sides. And 320 divided by 5 is 64. 64. You can check it with your calculator. And on the right side of the equal sign, you have r to the power of 3, because this will cancel. Okay, so can I change my 64 like to some base to the exponent of 3? Yes, if you check in your calculator, 4 to the power of 3 will give you 64. So this is 64 is equal to r to the power of 3. So this is my 64. I have changed. What I did is to cheat to have the same exponent. That's how you do it. So this is 64. Now, you can see that the exponents are the same. If the exponents are the same, according to the exponent rule, the bases must be the same. So R is equal to 4. Can you see that? Now we have our common ratio. Now to get the value of x, you take the previous term, which is 5, you multiply it by the common ratio, which is 4, and x is equal to 20. Now to get y, you take the previous term, which is x, and x is 20. You multiply it by the common ratio, and y is equal to 80. Can you see that? Okay, now let's move on to the next question, which is question B. Let's solve for B. I'm going to use this space. B. The question says, which term of the sequence is equal to 81920? So the question is asking for T what is equal to 81920. Or in other way, I can say the question is asking for the value of n. Can you see that? So we still need this formula to solve for n. Now my Tn will be replaced by this value. 81920 is equal to, what is A? The first term is 5. And what is R? We solved for R. We did it. We got it. It's there. It's 4 to the power of n minus 1. Can you see that? Now you can see that this 5 cannot multiply the 4 because the 4 is raised to some exponent or to some power. So the power comes before multiplication. Can you see that? So what we can do is to divide by 5 on both sides. So what is this equal to? Let's use our calculator. So I have this. It's 81920. You divide by 5. So it will give you 16. Can you see? 16384. So you have 16384 is equal to, this will cancel. So you remain with 4 to the power of, let me do this. You remain with 4 to the power of what? N minus 1. This is what we have on the right side. Okay, now we need to drop our exponent. This exponent, we need to drop it down. How can we do that? And we have a big number on the left side. We can't break this into exponent. It's so big. So what we do is to introduce log on both sides. So you're going to introduce log on this side and log on this side. Can you see that? And now this n minus 1 can go down according to the log rule. So it will be like this. This has dropped down, and then you have log 4. And then this side you still have your log 16384. And then we want to remain with n minus 1 on the right side. So you divide by log 4 on both sides. Log 4. Okay. Now let's do this in our calculator. What we have. So it is log 16384 over log 4. So on the left side we have 7 is equal to, and this will cancel. So you remain with n minus 1 this side. So you bring your negative 1 to the other side. So you'll have 7 plus 1 is equal to n, and n will be equal to 8. So which term of the sequence is equal to 81920? So it is equal to n equal to 8, or T8. So T8 is equal to this value. Okay, I think this is all for this video. I believe my video was of help, and I'd like to remind you to subscribe to the channel if you haven't subscribed, and I'd like to see your comment and your likes to encourage me to keep posting content like this. Take care and see you in the next lesson.